Okay, welcome. Hi, everyone. I'm Eric, and I'll start off by giving you a little bit of background. I'm not originally trained like this. I have a very eclectic training. I'm trained as a PhD in molecular biology, genetics, and cell biology. I did my postdoc in toxicology and pathology at the University of Michigan and Pfizer. Lately, I've been doing a lot of consulting and writing in R, and really where I first became experienced with R was in Pfizer. We had some more difficult analyses for a complex multivariate problem I had, and it was either trying to pay to get time on a proprietary software package or write my own. So I learned to write my own, and from that has stemmed the use of R. So I guess I'll cut right to this. Why did I start looking at a Trauma Director's Toolkit, and what does it do? So the Trauma Director's Toolkit is designed specifically for medical professionals to utilize with their data to aid them in injury prevention, diagnosis, or any other necessary analysis of this disease. And I'm going to specifically use trauma as a disease because we can look and see that it follows very specific probabilistic-based approaches. Well, it's not as easy as, say, diabetes or some of these others. You do have very specific underpinnings that we can use. And also, the thing I also want to kind of point out, as full disclosure, this was also done in conjunction with my wife. So it was a grant sponsored by my wife, who is the trauma director. She's a medical professional. She has a general surgery and a fellowship in critical care. So this was done, full disclosure, team wifey. So what's the initial reasonings and goal for this? And let me give you a little bit of the landscape. It hasn't been very long that we've really had 100% market penetrance or near 100% market penetrance of electronic medical records. So doctors are still starting to learn how their data fits in. And I also want to kind of couch this into a larger sort of philosophical discussion, I think, that belongs in LibrePlanet and free software, is in order to have a liberated user group, you need a free and ethical data, you need free and ethical software, and you need your free and ethical hardware. So what the part of this is to help bridge the gap between the proprietary software that we're seeing to take maybe exports from proprietary software and put them into the public space so they can be used by anyone, or if they already have a lot of hospitals will already have existing statisticians. The reason why we chose R is that it can be piped right into those already existing packages. So our goals from this started off is it needs to be in the free software GPL license ecosystem. And I wasn't originally aware of this. I've just been using free software for what seems like forever. I think I've been using LibreOffice since about, I don't remember, 28, 9, 10, around there, and I think had a couple of different names. But it's something that I've always found interesting because it seems like coming from the molecular biology standpoint, where we had a lot of proprietary, a lot of closed intellectual property, I saw almost what appeared to me to be as a stagnation in development, where you had to go through like a gatekeeper to ask permission to use it outside of the standard use. So that's why I chose that this should be in the FSS GPL software. Both the software and the packages should be scalable to larger data sets, as well as have the necessary tools for basic analysis. So why am I stating this? So a lot of times these trauma registries and the trauma docs and the trauma registrar will collect their yearly data and they'll upload it to a database on the state and then the national trauma database. Sometimes, not always, depending if you pay for the necessary added, I don't know if it's a package or how they classify it, they'll give you reports that allow you to benchmark back to the national standards. But there are very specific and very obvious different changes in demographic changes that you see. For example, a lot of this data was taken from Northeast Tennessee, where you're going to see a higher social vulnerability index. You're going to see a lower access to vehicles. You're going to see a higher rate of under and uninsured than, say, someone who's going to be in Boston or New York. So we want to be able to look at your stuff and to be able to compare it locally, as well as have some national guidelines. But this is where it gets to the need for the experts. So we need the expert to be able to easily modify it by any end user. So if they see an analysis is close but not quite for them, that they can just do it themselves. And we need to provide a summary and a graphical and accessible, because what we're seeing right now is machine learning, and I don't like the term artificial intelligence because you can't create something out of nothing, and I still haven't seen human intelligence yet. So if anyone sees that, point that out to me. But so what I'd like to see is that the medical professional will be able to apply it. There are very specific classification protocols that we can use that will help them earlier identify disease. And maybe this could even get to the point where we can start having doctors think about how to use their data on a real-time basis. Now, in addition to helping medical professionals, I think this gets back to the second part. How do we get this data into the public? We have a lot of very intelligent programmers out there. I'm just looking at a room full of them. We have very intelligent data scientists out there, but we don't often have easy access to this data. And it seems like other people have dealt with this. Not only is it just literature data, but it's basic patient data. So what I'm working on and working with the clinicians right now, working within the HIPAA framework, where we have very specific safe harbor and very specific experts that can determine whether or not the data can be released, we can then work with the function so that they can pre-blind them, and hopefully, I mean, I guess it would be ultimately upload it to, say, someplace like the Libra EHR system or some completely free electronic health resources where other people could then use to actually look and design new technologies. So finally, what this came out of was there was a recent merger that occurred in my wife's region. And it was difficult to write reports from your data. You could provide beautiful, simple summary bar charts and stuff like that, but it's difficult to write reports. And also the state of Tennessee is required to have a state report done, but I don't think they've actually done the report in 3 years. Since 2015, there hasn't been a state report put out, just saying. So we need the ability to write reports and figures as needed by the end users. It also helps to act as sort of an administrative pacifier. If you're in a large organization where they want to be able to put in their checkbox that you've done the necessary work, you can hand them this report to say your administrative report, and they're going to be happy. So it serves multiple levels. So what is the overall design? Our package, it's base, it's core, it's underlying. It's licensed under a GPL version X. There's multiple ones if you want to check, but it's pretty much all the GPL license ecosystem. The Trauma Director Toolkit package is a GPL v3. It can be anything you wanted or equivalent. It's easily accessible, so no gatekeepers. And what do I mean by that? Oftentimes in academia, you'll see people produce these great, I mean, they're packages and programs, but you have to go to them to ask them to get to it. And it acts as a gatekeeper or a barrier of entry. I don't want to have that. I want someone, if they want to use it, just to be able to download it and use it. So that's what I mean by no gatekeepers. So that's why it's currently on GitHub, or it'll be on GitLab or equivalent, and I hope to always maintain it this way. Because the one thing I have found from my perspective, if there's going to be a gatekeeper in place where you have to ask them, and sometimes you have to beg them, and what are you going to give for me, or what sort of data am I going to get in return, it ends up squelching and decreasing the innovation that can occur in that area. So right now, the initial functions are concentrating on the cleaning of the data, the mapping of the data, and a few other basic sort of items. The reports, initial work is using Markdown or RMarkdown. Usually I'll use RMarkdown in RStudio or Markdown because I haven't been able to get my Emacs hook to work correctly for the RMD files, but that's just me. Oh, and actually I should probably say that. I forgot. This was totally built on Emacs 26.1 using ESS. I didn't use anything proprietary. It's just kind of, why not? And the reports are easy to modify. In the Markdown, if you're familiar with any Markdown or RMarkdown, it follows very basic, early sort of HTML style or very basic Markdown style. So I found that most of medical professionals have no problems once you teach them, you know, 1 hash equals really big to 5 equals really small. I mean, they're off and going. So we needed this also to be operating system agnostic. What I'm finding is that you're going to have a range of different operating systems. Like you might have, in a group of 5 partners, you might have 3 using Mac, say 10 partners, 3 using Mac, 4 using Windows, and 2 or 3 using a mixture of Linux, and some will have a mixed household. And in fact, our household is a mixed household. We'll use multiple distributions of Linux, multiple Mac and Windows OS. And so this is, I think, common for what we're going to see in the medical professional. So we continue to choose to keep it operating system independent. So we start out with cleaning the data, and that's honestly about 80 to 95% of the time it seems like you're spending trying to get rid of weird, like, tildes and ampersands and stuff that are added to your zip codes, or cleaning the data from consultants that failed to incorporate or put in the correct zip codes. So a good chunk of this was spent just cleaning data from these exported sources. I think this will be actually easier if we can get direct electronic medical access, but again, we'll talk about that proprietary ecosystem and how that acts as a gatekeeper. The basic summary statistics are standard column statistics you're going to get. You know, your mean, median, your total range. You're going to see your ages. You're going to see where they're coming from. You can do county statistics. It's very just standard statistics. But what I found is looking at these statistics, I would find very specific areas I found interesting, but that would completely be glossed over by the medical professionals. So it came down to, how do we make this so that they can quickly see what their summaries are and look at areas that are areas of concern. So one of the charts we did was more of a scatter chart. So we took the average age and we broke this down by county. You can do this individually, but we chose not to do it individually so you couldn't identify anyone. And what this is looking at the county and the major subgroups that we see, or ICD, or international, international criteria of disease, I think. I can't remember the exact. It's the number 10. So we took those and I grouped them based on their overarching group. So if it was an all-terrain vehicle where, you know, you saw where we're from actually, I think is on record of having the highest octogenarian ATV crashes in the nation. So you're going to see a high number of ATVs. Falls, you're going to see, but now here's where we got to see that the doctors didn't get to see. They've always been told that falls correlate to older age group. And they've always been told that MVCs correlate within this major subgroup. Now they can actually see it. Before they couldn't see it and they didn't understand literally where their patient population was coming from. So taking this data, you can then overlay it on your previous one and determine if you're getting changes, difference, or we can even do, and we're working on looking at a differential sort of idea to see if there's been an increase or decrease among those specific sort of ICD-10 groups across your different counties or across your different regions. So as I said, people need to see where this is coming from in order to help compare. What you're looking at here are just 3 different ways of looking at the maps. The most common way that you do is they'll just ICD-10 group it or put everyone on, throw it on a standard Google map, which gives you a great idea of how the geography is. And as you can tell, it's very clearly limited by the Appalachian Mountains. From here, you can then further take a 2-dimensional statistical density, and what does our whole cohort look like? And what you're seeing is a very common and expected, let me move out of your way so you can see, common and expected outcome is that it correlates strongly to where population densities are when you include all of the groups. But considering 50% or so of most traumas are under an injury severity score of 10, which is not a high severity score. I mean, you're hurt, I'm not saying, but it's not high for trained trauma for professionals. Is there a skewing of this data? So, for example, if you live in a city, you're going to have better access to EMS, and that EMS is quickly going to take you to your tertiary referral system. If you live out in rural America, you have a lower access rate to EMS. It's just the nature of care. For example, when on the volunteer fire department I worked on for years, we would take on average 15 to 20 minutes to get to a motor vehicle crash, whereas a friend of mine And that was fast. That's if it occurred right next to the station. Most of the time, it would take 15 minutes just to get to the station, then another 7 to 10 minutes to get to the crash. Whereas you compare this to, say, someplace like Tampa, Hillsborough County, they're within 7 minutes of actually having an advanced life support rig being on scene. I mean, when we're talking where time counts, that's a big difference. So what you see here, when we separate out how these injury severity or how these injuries distribute based on severity, what we see is kind of what you would expect. You have a population-specific density distribution around where you have high access to cities or high access to EMS providers. Where you see a decrease in that axis, you see a spread out. So it becomes more of a uniform distribution that's related to the distance instead of the distance and population density. What was also interesting that came out of this, during the time that they were doing this work, and this is across 3 years of medical records, during the time they were doing this, they had a decrease in the number of registrars, so they had to bring in a consultant group, a highly rated consultant group, and they took the time in entering their medical registry to bring it up to the state standard. But what was interesting to me is that they failed to introduce the injury severity score on a chunk of those records, so we could quickly pull out that which records they probably entered and where they were. And so it's just kind of interesting side note that sometimes you got to check who you're hiring for your outside vendor provider. As we talked about, travel times are important, and why was I talking about it's very important that if you're within 7 or 8 minutes to an advanced life support rig, how that can be very effective. So there's something in trauma called a golden hour. Now, it's not exactly an hour. We believe the sooner you get a patient to definitive medical care or a tertiary or quaternary hospital with the necessary advanced practice surgeons, the necessary specialists, the necessary equipment, that they have a higher probability of survival. This is just a kind of a central tenet of trauma. And you see this as early as, like, say, the late 60s with a lot of the trauma surgeons who went on to form our current trauma system with their experience in, specifically in Vietnam, where it was, I think, a 7-minute evac rate from the front to a secondary hospital. So what we wanted to look at is how do these patients enter? So this is the standard stat density here. And overlaid on top of that, where are the referring hospitals coming from? And what we see is that there are specific correlations with very specific hospitals that receive patients that end up later going on to a trauma center. Now, why is this important? Because the golden hour is defined as time to definitive care. If they're sitting there from 3 in the morning after a bar brawl, again, just using an example, till the next time, until 7 in the morning when the ER shift comes on, that's a 4-hour delay to definitive care. So the goal here would be to allow the trauma director to quickly target which hospitals or outlying hospitals are holding on to the patients, determine if they're holding them on for longer than necessary, or to look at the injuries, and then enter into appropriate sort of injury prevention program or process improvement or quality improvement program to decrease the probability that this happens. So as I said, this was part of more than just an initial idea. Initially, this was designed as an injury prevention sort of process improvement program that could work with any data. But last year, I think it was last year, January, there were 2 hospital systems that were in this. There is the Bristol Kingsport. They were part of something called the Wellmont Hospital System. And then there was Johnson City, right here, which was called Mountain States. They merged. Part of the merger was founded under what they called a COPA, which is basically a way to circumvent FTC monopoly rules because of the market penetrance here. What they did is they decided to move the trauma center to Johnson City based on their data they had. We were not able to analyze their data, but we were able to use public data to see, well, what is the impact going to be on the travel time? So we started with the golden hour, and anyone who's under an hour pretty much they were going to stay statistically close enough to that golden hour, it probably would not have affected their outcome. But where it got interesting is what happens if we look at the patients that we know are already going to take an hour to get to this one medical center? What is the delta difference to going to other medical centers? So again, just using publicly available data that's taken from the 21 counties that are designed to regulate this merger, and for an example, that would be right these counties, about like that. Nothing in North Carolina, Southwest Virginia, and Northeast Tennessee only. So just taking either census data or what I used was county zip code data, you're able to then determine anything that's over an hour or under an hour is thrown out. Anything over an hour is set at 0. So what we found out is that when you look at this, only 4 of these regions had a shorter travel time to the currently selected trauma center. 41 of the COPA had a longer travel time total. And what you're seeing is that you see a demarcation of 4 or 5 different ways of how you get into this. Why this is following very specific lines is you almost always had to go by that trauma center to go to the other trauma center. So that's why you had this many here. So after they're in the trauma center, what do? I mean, you can do a whole range of different things. But is there a way, when they come in, based on their injury severity score, we can predict how long they're going to stay? Yes and no. So this is the initial linear modeling, a standard basic machine learning model to look at a correlation between length of stay and injury severity. So usually I think in order to get a more accurate model, we would probably have to subgroup this correlating to, first off, we have different groups of trauma severity, so mild, moderate, severe, and profound. Secondly, we're also going to have to adjust for medical or socioeconomic risk factors. This did not do this. This is just truly a back of the envelope or an easy, simple proof of concept. Can this be used, and can we use this to look for leverage events? So first, we just took the entire population and looked. How does our injury severity score correlate to total length of stay? And we saw a pretty decent correlation. But what I kept finding interesting, and I'm not sure that these are, but more than likely, these few up here are what you're going to have people that come in highly injured, but will have a very low length of stay. What type of people do you think those would be? Dead ones. So yeah, it is kind of cheap. I mean, it's $1.21 a day to run a morgue versus $10,000 a day to run an ICU. So if you're looking at it from a business model, this is what I want to show, how averages can throw you off a little bit. But so when we did this, we were able to get a more accurate representation of what the average is like and not take into account kind of a confounding variable of death. The next question some of these doctors had was, is there a way that you can help me predict when my patients arrive? And yeah, I'm not going to be able to say on 10/27 in October, you're going to have this exact patient. No. Like, is there a way that you can aid in the correct and appropriate staffing and maybe even further kind of delve into where are my drivers of this population? So first and foremost, just started with a simple time series, absolutely simple. Looked at geriatric or pediatric, and then not geriatric and not pediatric. So one of the big drivers in the state of Tennessee was they feel that linking pediatric care and trauma care, and two independently distributed variables, is a good idea. So they linked funding directly to whether or not you have a pediatric hospital there. So my question, like first and foremost, you're seeing that when it comes down to trauma, on average, and this also holds true nationwide, it makes a very low percentage, and it's actually decreasing. On a nationwide scale, the pediatric trauma is decreasing because of a lot of our safety features. Better car seats, better just not using the mom seatbelt anymore, just a lot of common sense things that we now apply that weren't applied. We're seeing literally a slow but steady decrease in the probability of a pediatric trauma showing up. On the flip side, if you're not pediatric or you're geriatric, and in fact, we're seeing where we're starting to see what could potentially be an increase in geriatric due to immigration. It's a income tax-free state, so you see a lot of retirees showing up in the state. So my guess is due to like that form of immigration, you're going to see an increase in geriatric sort of trauma. But what you see here is these maintain relatively very similar. They follow what looks like a seasonal distribution. So when I ran it through an ARIMA model to look as, does this follow kind of a white noise? Does this sit around 0, go up and down? And can we predict it? And no, you can't, not without seasonal adjustment. But you can get close after you seasonally adjust. So using the forecast package in R, I was able to basically seasonally adjust, and this is looking at the full cohort. This is not isolated. Seasonally adjust, so you're seeing the full cohort up top, the theoretical adjustment, the trend line, and then the kind of the residual differences. Now, where this was taken from, this data was taken from, it's smack dab in the Appalachian Mountains. And if you're familiar with certain people, I believe there's one politician running for West Virginia said he saw better health care and better care in Iraq than he does here. This could probably hold true. So what you're seeing here is the implementation of the individual mandate of the Affordable Care Act. And again, this is correlation without causation, and then the repeal of the individual mandate. So we went from, I'd say probably 50% uninsured, underinsured, to maybe dropping that down a major percentage. And what you see, and I did not expect to see this, to be honest with you, because it's a trauma. You're just going to show up for trauma. You don't have a choice. But apparently people do have a choice. So that is one of the things I found interesting. I'd like to kind of expand on that. So then we took and said, okay, now that we have this model built in, can we predict where our patient population is going to be? And yeah, you can. Of course, you get broad error bars. You're looking at gray at 85% or dark gray at 85%, light gray at 95% confidence intervals. And it is held true, but I mean, such a broad spread of, it'd be a major event for it not to hold true. So where are we at, and kind of this is where this is kind of up to date and kind of where are we going. So currently I'm refining this package. It's really basic. It's really a minimum viable product, absolute minimal product. And also, to borrow from Sun Tzu, no program survives first contact with the end user. What I'm finding out is that as soon as you get something that works perfectly in your hands, it really doesn't work perfectly, it works in your hands, you give it to someone else who thinks can use it, they do things you never thought were possible to destroy it. So I'm learning. So quickly, I'm going back and integrating some of these functions to make it easier for the end user and the medical professionals to basically just enter in that they want it blinded, and it'll go through and blind it for them and automatically pull out the columns they're not supposed to have. They're just, medical doctors on average are very busy and overworked, so you have to make it as easy as possible for them to give you the data. So I'm also working on cleaning and continued report development. There's a lot of stuff I could not cover because it has directly identifiable patient information. But we have very specific machine learning modules and items like that that can help pull out very specific patient records to then increase your process improvement and your quality improvement programs. So one of the key factors in closing the loop in trauma is making sure that if you find someone that does not fall within what you'd consider average care or accepted standard care, that you bring it in front of a multidisciplinary committee, you discuss it, and you find ways of improving it, quality improvement program. So there are certain areas that we're working on these reports to automatically pull out that would not fall under the standard filters. So those people that maybe stayed longer than they should have. And what was interesting, we were finding that when you start doing that, you find that there's oftentimes downstream bottlenecks that prevent you from getting these patients out of the hospital. So again, a summary, this isn't an exact patient, but if you have someone who has mental disabilities and needs very specific care, it's very difficult in rural America to find a facility that you can transfer them to take care of their long-term care. So a lot of these length of stay analyses and other these analyses we're pulling out, we're finding that there are items that were completely unrelated to the hospital, but related to the entire patient experience. So next thing we're including principal component analysis and some basic neural network machine learning. What we're finding is that with some of this data, where there's correlations that doctors see, oftentimes simple linear models don't, and it's following more of a non-linear model. So in order to follow kind of, to quote Henri Laplace, probability theory is just mathematics reduced to common sense. So that's kind of what I'm trying to do here, to help these doctors, like, I want them to be able to look at that and say, this is just common sense, what took you so long? I mean, that makes me think, I mean, it's frustrating, but it makes me think that I did my job right. And finally, I'm looking at the development of automated blinding of patient health information and any protected information. It's easy to take care of the basic 10 to 14, but where we have problems is these combinatorial problems. So if we release this data, how do we prevent people from recombining it and identifying these patients for nefarious uses? And so this is, again, where I talked about earlier. I wanted to talk about the philosophy of data. This is where I think we need more of a moral and ethical sort of guidelines, I don't know if you'd call it, to the use of data. Like, if you're going to use this, I have no problems using it for medical treatment, but don't use it to market someone the next sort of catheter or the next, sort of Band-Aid. And actually, this is one thing, and the removal of direct database queries, what was interesting to me, and no names will be mentioned, and it's been 2 different EMR groups, not LibreHealth, the proprietary ones. They do not want to let you know what their backend is to make it easy for you to integrate with their report generation. And part of that is they wanted to keep you in their sort of like walled garden ecosystem. If they write the reports for you, they can charge you for the reports. You have to stay in their ecosystem. It's a great model if you're looking at extracting maximum amount of money, but not necessarily the best in medicine, in my opinion. I think that that's where we need more of a disseminated and participatory model. Getting back to this merger, there are 3 different hospitals, all had 3 certified state trauma centers. Each one was on a slightly different version of the underlying database. And one hospital had a completely different EMR. To get validated, correlated data would have taken a data scientist probably 6 months just to change one was on ICD-9 codes instead of ICD-10, and just little things. So that's where, if we're able to decrease the proprietary interaction and go directly, I think that we'll be able to kind of develop a more cohesive medical environment where one doctor can speak to the other and they're speaking on the same level. Not one speaking about one specific quirk of their registry, another one speaking another quirk of their registry. So in conclusion, or as a statistical program, along with the Trauma Director Toolkit package. It's a very minimal program that can be used for any analysis, blinding, and blinding of patient data. And over here, just basic to show where some of your trauma centers are in the Southeast. I think the Southeast was a great test subject because there's a mixture of both American College of Surgeons, state certification, and non-certification? No, almost all states have some sort of certification, but there's a great coefficient of variability. So when you take the state certification and try to correlate it directly to, say, patient or to the ACS, not all states look the same as American College of Surgeons. So this is an operating system independent that can be used in several commercially available systems. Anyone who's familiar with your commercial available ones, they have usually an R package that you can just pop R in there. It provides a basic set of tools: target injury prevention, show your encatchment area, determine where they're coming from. Future iterations are going to include basically potential customization, more machine learning, calculation of social vulnerability index, which gets really interesting when you come to correlating your social vulnerability index, access to vehicles, and trauma care needs. And then we're also working on direct database access via the dbplyr package, and that's again in the Tidyverse ecosystem. So together, this is meant to work with your medical professions to aid them in sort of better treatment of trauma, but this is not just trauma specific, can be used by any sort of individual they choose. So acknowledgements, I'd like to acknowledge Dr. Tiffany Lasky. She's my wife, so I guess this would be granted by the Lasky-Oli Foundation. She's the trauma director at East Tennessee State University and Holston Valley Medical Center. Vanessa is the registrar. She's basically was awesome at working with something they call DI Driller and giving me the access to the CSV files. And Sarah, she's a surgery resident that kind of helped us with this and recently did a poster presentation. The Free Software Foundation team, I really would like to thank you guys, because I've kind of opened, from someone who kind of lives in my own little Northeast Tennessee world, there wasn't a lot of information about free software. And the Free Software Volunteers, LibrePlanet, and everything has helped me along this way. I came from a proprietary system, so to see how to do this is huge. Our core team, just having R is great. And then, again, all these R packages, Tidyverse, ggMap, Geosphere, Forecast. Without other users, I guess on the backs of giants, we're able to make our discoveries. So without other giants and other people like that helping, there's no way this could have happened. All maps were using the Google Map API and the ggMap package. All Google Maps are required marking and data providers. And then some of those maps you'll notice we're using Stamen maps. Those are the open source maps. So yes, you can use open source maps. It's just at the time the Google API and the ggMap API and open source maps were fighting. That's the best way I can word it. It was not taking my bounding box sizes, it's just being hateful, so it was just easier to run the Google Map API. But ultimately, it would be nice to move it to a full open source map. So, any questions, comments, complaints, tomatoes?
Hi. Test.
So it's not a question, it's more, I perked up when you mentioned Appalachia, because that's kind of where I live, although I live northeast of your region there. I'm in central PA.
Okay.
But I also work in search and rescue, and
yeah, me too.
A lot of the accidents you reported are very recognizable to me, especially the ATV, a lot of fatalities in that. But I also saw that, my sister-in-law is she's an expert in rural medicine, so they recruited, she did the whole northwest of the U.S., and then Australia recruited her, and she went there for 8 years, and now she's back in Spokane. And I was thinking, I really need to show her your presentation, because I'm sure she'll be able to use it in some way.
Yeah, and more the merrier. I mean,
yeah, and then my college roommate's doctor in Missouri, I can think of a zillion people who would benefit from this. So thank you, is what I want to say.
Oh, thank you.
Question from IRC, and can you put up the link to the source code? Where can they find that out?
Just github.com, Eric43. And it's also, if the PDF on the slides, that should be an active link. And also I'll be working, there's another one I'm working on to put on, it's called the acute care emergency surgery. So we're looking at timeline differences between patients that have access to 24/7 general surgery call coverage versus patients that will show up and there's not an in-house sort of general surgeon. So there'll be other packages.
So I came in late, and apologies if you covered this, but have you released a paper or anything with this data and this analysis that you've done so far?
We had a poster, and then I'm working on writing the manuscript right now. It's just trying to, I find it, from my perspective, I like presenting, and it helps me sort of set my thought and get feedback before I fully write it. But yes, no, it is actively being written, and also I had a request from another doctor that I do a small video series on how to use it. So I'll probably end up having to do that too. So if anyone wants to help me kind of wrangle the cats, I'd be greatly appreciative.
Hi, I worked in North Carolina, Eastern North Carolina in the 80s with a health, it was the North Carolina Rural Health Coalition. And one of the things that we noticed, this was when I was very young and I was more of a community organizer, but the doctors I worked with noticed that there was a high incidence of cancer, and we were thinking that it had to do with some of the toxins that were in the soil or whatever. And I wondered, you're doing this work, but if you have ever mapped like that kind of work?
It could totally be done. A lot of times you run into that with your multiple hypothesis problems. So you have to go back and simulate that. But no, that is very useful, and it would be, I think, and there was online, it wouldn't surprise me if they have any density maps like that. I'm surprised they don't. If they don't, I'll make it, because it would be really interesting to know. It just would be a really cool map. Yeah. Especially I'm trained in cancer. I did a lot of my last work was on an immunotherapy clinical trial. So it would be for stage 4 breast cancer. So it'd be really interesting to see that.
Any more questions? Awesome, great.
Thank you. Thank you for attending.